Hello, it's Tochikele Wademba from Special Maths Academy, and in this video, I'll be solving the problem 3 from the NMC first round. So here we're asked to let delta denote the area of a triangle ABC, and then I tried to show that I asked to show which of this is false, right? So they're given 5 options here. Root of ABC times A plus B plus C is equal to area. AB plus BC plus CA is greater than or equal to root 3 area. A plus B plus C all squared greater than or equal to 3 root 3 area, and A squared plus B squared plus C squared greater than or equal to root 3 area, and ABC over A plus B plus C is greater than or equal to area all over 3 root 3. So we have these 5 options, and then we have to show which of this is false. So in an exam situation, it's enough to pick an example or to pick a particular scenario, a particular example, and show that one of these options doesn't work for that example. Because for any of this to be true, it has to work in all scenarios. So if there's a particular scenario that it doesn't work for, then it is false. Right? So all we have to do is just find a suitable example, and then find which one of this is false for that example, and then we'll be done. So to do this, let's pick the 3, 4, 5 triangle. Why I decided to pick the 3, 4, 5 triangle is because we know its length and we can easily calculate its area. So it's the fastest way to go about it. So the area delta is equal to 3 times 4 over 2, which is equal to 6. We have A is equal to 3, B is equal to 4, and C is equal to 5. All right, so now let's try all the options and find out which of them is false. So let's start with option A. We have roots of ABC times A plus B plus C to be equal to 3 times 4 times 5 times 3 plus 4 plus 5, which is equal to 3 times 4 is 12 times 5 is 16, and 3 plus 4, 7 plus 5, 17. So root of this. And now this is definitely not equal to delta, which is 6, right? So we already have a contradiction here, and that means that option A is actually an answer, right? So you can quickly do this, right? This is an objective exam. You can quickly do this in an exam situation. But for the sake of this solution video, I'm actually going to show that the rest of them are actually true. Now we have that A is false because A doesn't work in this situation. A doesn't work in this scenario. So that's definitely an answer. But for the sake of this solution video, I'm actually going to show that the rest of them are actually false. Now, to show this, right, the first thing that comes to mind is to take each of the options B, C, D, and E one by one and show that they're actually true, right? That works perfectly fine. But a smarter way to do this is to actually show one is true, then show that if that one is true, the rest of them are actually true as well. So it's faster and more efficient to do this way. So I'm actually going to show that E, that's option E, implies B, C, and D. So basically, if I can show that, I'm trying to show that if I can show that ABC over A plus B plus C is greater than or equal to delta over 3 root 3, then the rest of them are actually true as well. That's option B, C, and D, right? So to do this, I'll have to show, I'm going to show 3 things. The first is that AB plus BC plus CA is greater than or equal to 9ABC over A plus B plus C. Then A squared plus B squared plus C squared is greater than or equal to 9ABC over A plus B plus C. Then, of course, A plus B plus C squared is greater than or equal to 27ABC over A plus B plus C. Now, if I can show this tree, then what this implies is that if this is greater than or equal to this, and I can show option E, which is ABC over A plus B plus C is greater than or equal to delta over 3 root 3, then this means that this is in fact greater than or equal to 9 times delta over 3 root 3, which is equal to root 3 delta, which is what we wanted. Also, in the same vein, this is greater than or equal to 9 times delta over 3 root 3, which is equal to root 3 delta, which is what we wanted. And this is greater than or equal to 27 times delta over 3 root 3, which is equal to delta 3 root 3 delta, and which is what we wanted. But first, I'll have to actually show that these three are true. So we don't know that yet, right? We actually have to show that they are true. Right now, so at this point, these are all hypotheses. We don't know that they're actually true. So I actually have to show that these three guys here are true. And of course, option E, which is ABC over A plus B plus C, greater than or equal to delta over 3 root 3, is true as well. So if we can show these four, then we are done. Right? Because the last one implies the other three, or the last option implies the other options if these first three are true. So if we can show all four of them are true, then we are done with showing that B, C, D, and E are actually true. So now I'm going to take this as separate entities and actually try to show them one by one. Right? So basically, let's start with a proper solution. Now I want to show that ABC is greater than or equal to 9 ABC over A plus B plus C. Now this is true if and only if AB plus BC plus CA times A plus B plus C is greater than or equal to 9ABC. I'm putting the question mark on top to indicate that we're actually working backwards, right? So it's also indicated by the if and only if symbol. But the question mark is just there to indicate that the if and only if symbol is actually going backwards, right? That means you have not established these guys here. You have not established them yet, and we'll establish them at the end. So that's what the question mark is there to indicate that the if and only if symbol is actually going backwards. That's working backwards, right? So let's continue with what you are doing. We have to show this, right? So let's expand. This is true if and only if A squared B. That's when we expand that, plus AB squared plus B squared C plus BC squared plus C squared A plus CA squared plus 3ABC is greater than or equal to 9ABC. And then of course, we can carry 3ABC to the other side and then we'll have this greater than or equal to 6ABC. Now, like I said, we are working backwards, so we just have to show. So this is actually what we want to show. Now we are going to show this using AMGM directly. So basically we have that a squared plus ab squared plus b squared c plus bc squared plus c squared a plus ca squared over 6 by AMGM is greater than or equal to the 6th root of what we get is when we multiply all of them times ab squared plus b squared c times bc squared times c squared a times ca squared. And this is actually equal to the 6th root of a raised by 6, b raised by 6, c raised by 6, which is equal to ABC. So this actually implies that a squared plus b plus ab squared plus b squared c plus bc squared plus c squared a plus ca squared is in fact greater than or equal to 6abc. So this is true, which implies that what we have at the beginning is also true as well. Right, so this implies that this is true. And I'm done with the first part of what we wanted to show. So let me just mark that here. Right, so these are the first things we wanted to show, and we have shown the first one. So now let's move on to the second one. The second one is to show the second one. What we are going to do now, we are going to show that we are going to use AMGM again. But this time, we'll use the fact that a squared plus b squared is greater than or equal to 2ab by AMGM. Also, b squared plus c squared is greater than or equal to 2bc. And also c squared plus a squared is greater than or equal to 2ca. So this implies that 2a squared plus b squared plus c squared is greater than or equal to 2ab plus bc plus ca. And of course, this implies that a squared plus b squared plus c squared is greater than or equal to ab plus bc plus ca. So now this is the fastest way to show the second one, because we have already shown that ab plus bc plus ca. We have already shown in the first one that ab plus bc plus ca is greater than or equal to 9abc over a plus b plus c. So of course, this implies the second one, which is a squared plus b squared plus c squared greater than or equal to 9abc over a plus b plus c. And then we have shown the second one, right? So now we just have to show the third one, right? And that's a plus b plus c all squared is greater than or equal to 7abc over a plus b plus c. So again, I'm going to use this first one. Again, I'm going to use the first one as a link. So what I'll try to show actually is that a plus b plus c squared is greater than or equal to, I'll try to show that a plus b plus c squared is greater than or equal to 3 ab plus bc plus ca, right? And again, we are working backwards. Why do I want to show this? Because if we can show this, then ab plus bc plus ca is greater than or equal to 9abc over a plus b plus c. Then similarly, we'll have we'll show what we want to show. So we can expand again. We are working backwards for this one. So this is true if and only if a squared plus b squared plus c squared plus 2ab plus bc plus ca is greater than or equal to 3ab plus bc plus ca. And then this is true if and only if a squared plus b squared plus c squared is greater than or equal to ab plus bc plus CA. But you have already shown this here, right, with AMGN. So this is true, which implies that this is true. So basically, like I was saying, A plus B plus C all squared is greater than or equal to 3AB plus BC plus CA, and then which is greater than or equal to 3 times 9ABC over A plus B plus C, which is equal to 27ABC over A plus B plus C. So then, of course, this implies that A plus B plus C squared is greater than or equal to 27ABC over A plus B plus C. And then we are done with the third one as well. And so all that's left for us to show is option E. And that's ABC over A plus B plus C is greater than or equal to delta over 3 root 3. So like I said, if we can show this, since you have shown the first three, then if we can show option B, then that implies that B, C, and D are true as well. So that's what we are going to work to prove now. So we are trying to show that ABC over A plus B plus C is greater than or equal to delta over 3 root 3. So of course, again, we are working backwards. So we are going to use the fact that the area of a triangle is equal to ABC over 4R, where R is the circumradius. Where R is the circumradius. Right, so we are going to use this fact. So this is true that ABC over A plus B plus C. So this is true if and only if ABC over A plus B plus C is equal to ABC over 4R times 3 root 3. And of course, this is true if and only if 1 over A plus B plus C is greater than or equal to 1 over 12R root 3. So now those two are both positive. So we can safely cross multiply to give us that this is true if and only if 12R root 3 is greater than or equal to A plus B plus C. Now, right, so this is what we want to show now. So basically, but this is what we want to show, right? But for the sake of this solution video, I'll actually show a better case of this, which in fact is kind of a lemma. So I actually show that 3R root 3 is greater than or equal to A plus B plus C. This is what I'm going to show now. Of course, 12R root 3 is greater than or equal to this. So if we can show this, then it's going to imply this, right? So basically, this is what I'm trying to show. And to do this is what I'm trying to show. 3R plus 3 is greater than or equal to A plus B plus C. And to do this, I'll use the sine rule, which says that A over sine A is equal to 2R, or A is equal to 2R sine A. Now, similarly, we'll have B is equal to 2R sine B, and C is equal to 2R sine C. So we are going to replace A, B, and C with 2R sine A, 2R sine B, and 2R sine C. So this is true if and only if 3R root 3 is greater than or equal to 2R sine A plus 2R sine B plus 2r sine C. Now, this is true if and only if 3r root 3 is greater than or equal to 2r. So sine A plus sine B plus sine C. Now, of course, r goes with r, and then we'll just have to show that 3 over 2 root 3 is greater than or equal to sine A plus sine B plus sine C, or we can put it like this: if and only if sine A plus sine B plus sine C is less than or equal to 3 root 3 over 2. So now this is actually what we want to show, right? And if we can show this, then we are done, right? Because this is going to imply E, and then E implies B, C, and D. So if we can show this, then we are done. So this is actually why I decided to use this instead of what the problem led us to. So I decided to use this instead of this. I decided to use this instead of this is because this is actually a known lemma. So I just decided to introduce it in this solution video. So to enlighten or to inform viewers. So, and of course, but this implies this, so we are safe showing this, right? So this is actually a known lemma, and there are many ways to show this, but for the sake of this solution video, I'll be using the Jensen inequality. So now the Jensen inequality says that if a function f is convex in interval I, then not actually Jensen inequality, but a corollary says that then f of x1 plus f of x2 up to f of xn over n is greater than or equal to f of x1 up to xn over n. Now this is for if f is convex, right? But what I'm going to use is the inverse of this, or the converse of this, which is for when f is concave, right? So when f is concave in the interval, then f of x1 up to f of xn over n is less than or equal to f of x1 up to xn over n. Now this is what this is the not the Jensen inequality directly, but a corollary to the Jensen inequality. So this is when f is, let me just separate that. This is when f is convex, and this is when f is concave. And this is what we are going to be using to show this. So the sine function, sine x, is concave in the interval 0 pi, which is 0, 180 degrees, right? So sine is actually concave in that interval. We can check this by showing that sine, this is actually less than or equal to 0. So basically, you can check this by showing that, but sine is concave in that interval. So this gives us that sine A plus sine B plus sine C over 3 is less than or equal to sine A plus B plus C over 3, which implies that sine A plus sine B plus sine C over 3 is less than or equal to sine A plus B plus C. A plus B plus C is 180 degrees. And of course, that is equal to, and over 3, that is equal to sine 60, which is root 3 over 2. And basically, we have what we want, which is sine A plus sine B plus sine C is less than or equal to 3 root 3 over 2. So this is true. And if this is true, then this is true. If this is true, then this is true. And of course, if this is true, then option E is true. So we are done. Right, so we have shown all four, so we are done, right? So basically that's that for this problem. So you can see it's pretty long, or it's actually pretty long to actually show option B, C, D, and E. So that's why I said that in an exam situation, you're actually better off just picking an example than showing that option A is false for the example, and you'll be perfectly fine. So, but for this solution video, I actually made the solution videos to show that B, C, D, and E are actually true, and introduce this lemma, which is introduce this lemma, which is A plus B plus C is introduce this lemma, which is A plus B plus C is less than or equal to 3R plus 3. Right, so that's that for this video. Thanks for viewing. We'll see you in the next video. Ciao, ciao.